My sincere greeting to one and all. I'm Tamanna from BSc Chemistry Honors second year. Today I'm here with chapter Acids and Bases. 7.1 Arrhenius concept of acids and bases. Arrhenius, a Swedish chemist, was the first to define acid and base in aqueous solution. According to Arrhenius, an acid is defined as a substance which contains hydrogen and which, when dissolved in water, gives hydrogen ions. Accordingly, all mineral acids like HCl, HNO3, and H2SO4 containing hydrogen when dissolved in water dissociate completely into hydrogen ions H positive as HCl gives H positive plus Cl negative in water. HNO3 gives H positive plus NO3 negative in water. H2SO4 in water gives H2 moles of H positive plus SO2 SO4 2 negative. Arrhenius named after these acids with which dissociate completely in water are strong acid. Therefore, the other acid like acetic acid, carbonic acid, and phosphorus acid are when dissolved in water do not dissociate completely into ions. As a result, an equilibrium is set up between the ions and the undissociated acid molecules as shown below. Arrhenius named these acids as weak acid. Accordingly to Arrhenius, a base is a substance which contains hydroxy group and when dissolved in water gives hydroxyl ion OH negative. The substances like NaOH, KOH which when dissolved in water dissociate completely to give hydroxyl ion O positive ion as NaOH gives Na positive plus OH negative in water. KOH gives K positive plus OH negative in water. Arrhenius named these bases which dissociate completely in water as strong bases. The substances which do not completely dissociate in hydroxide ion, Arrhenius named them substances as weak bases. For example, substances like NH4O negative, NH4OH, MgOH twice, AlOH3 do not dissociate completely to give OH negative ions and can be written as the following hydrogen ions H positive obtained from these acid and hydroxyl ion OH negative obtained from the bases comes together to form unionized water. Arrhenius described the combination of H positive and OH negative ions as neutralization reaction. For example, NaOH give Na positive OH negative and HCl give H positive Cl negative. Combining this reaction of NaOH is 7.1 and then another is 7.2. Combining right hand side of 7.1 and 7.2 we get Na positive OH negative plus H positive plus Cl negative give Na positive Cl negative plus H2O. Cancelling the common ion in between both sides of 7.3 we get H positive plus OH negative is equal to H2O neutralization. Arrhenius concept is very simple to apply and explain a number of phenomena like neutralization, hydrolysis of salt, strength of acid and bases. However, there are certain limitations which are described below. Arrhenius concept of acids and bases is applicable only in a aqueous solution. This concept fails to explain the acidic and basic behavior of substances in a non-aqueous medium such as liquid ammonia, liquid sulfur dioxide, alcohol, etc. Second, Arrhenius concept failed to explain the acidic character of substances like CO2, SO2, and SO3, etc. The basic character of substance like NH3, Na2CO3, CaO, etc. Third, Arrhenius concept also fails to explain the reaction between an acid and a base in the absence of water. For example, NH3 in gas and plus HCl in gas gives NH4Cl and Na2O plus SO3 in gives Na2SO4. Although Arrhenius concept of acid and base suffer from a number of limitations, yet the concept is very useful and informative for an elementary approach. Bronsted-Lowry concept. Arrhenius concept of acid and base was further improved by Bronsted and Lowry. Both Bronsted, a Danish chemist, and Lowry, an English chemist, in 1923 incidentally introduced the same definition for acid and bases according to Bronsted. Lowry experiment concept. An acid is a substance which can donate a proton H positive, where a base is a substance which can accept an proton H positive. In other words, an acid is a proton donor, where a base is a proton acceptor. As a result, Lowry-Bronsted concept is sometimes called the proton donor acceptor concept. It can be represented as acid gives H positive plus base 1 proton donor, base 2 plus H positive give acid to proton acceptor. Accordingly to Bronsted-Lowry, a neutralization reaction involves the release of proton by an acid and the acceptance of that proton by a base. For example, the reaction between HCl and NH3 to form the salt ammonium chloride can be represented as. The curved arrow shows how electrons may rearrange to result the transfer of hydrogen atom from the acid to a base. The unshared pair of electrons on the nitrogen of ammonia is attracted by a partial positive charge on hydrogen in the polar hydrogen chloride molecule. The comparison of the substances of bonded the reactant and product show that there are hydrogen atom which is bonded to chlorine in the reaction is bonded to the nitrogen in the product. Thus, a proton has transferred the chlorine to nitrogen as act as a Bronsted-Lowry base. The special must the species must have at least one unshared pair of valence electrons so that it can be form a covalent bond to the proton. The to act as a Bronsted-Lowry acid, a species must contain at least one hydrogen atom that is attached to an atom that is more electronegative than hydrogen. In the case, HCl loses a proton, and in an acid, ammonia accepts a proton from HCl and is a base. So, some other examples of acid-base reaction according to Lowry-Bronsted concept are acid proton donor, base proton acceptor. HCl plus H2O gives H3O positive plus Cl negative. H2SO4 plus H2O gives H3O positive plus HSO4 negative. H2O plus NH3 give NH4 positive plus OH negative. It is important to note that the above examples, the water act as a base which, with respect to the hydrochloric acid and sulfuric acid. Interestingly, water act as an acid with respect to ammonia. Such a substance which acts as both acid proton donor as well as base proton acceptor is called amphoteric or amphoteric substance. Similarly, bicarbonate ion HCO3 negative behaves as an acid and a base. Other example of amphoteric substances is hydrogen sulfate ion HSO4 negative conjugate acid and base pair, but an re-evangelate reaction between an acid and a base HCl plus NH3 give NH4 positive plus HCl negative. HCl being an acid donate and proton in the form of Cl negative ion, where ammonia being an base accept a proton and form ammonium ion NH4 positive. Now the chloride ion Cl negative has a tendency to accept the protons, where ammonia ion NH4 positive has a tendency to donate a proton. In other words, an acid donate a proton and because a base accept a proton and become an acid. Thus, a base formed from an acid is regarded as the conjugate base of an acid. Similarly, the acid formed from a base is called the conjugate acid of the base. In the example between between HCl and NH3, Cl negative is the conjugate base of HCl and NH4 positive is the conjugate acid of NH3. Acid and bases that are related by a loss or gain of H positive ions are called conjugate acid base pairs. Thus, Cl negative and HCl, NH4 positive and NH3 are conjugate acid base pairs. We can represent the acid base pair as acid gives conjugate base plus H positive ion, base plus H positive ion give conjugate acid. It is clearly indicated that an acid base reaction would involve two acid and bases. These act as these acids and bases are called conjugate pair. For example, acid 1 plus base 2 give acid 2 plus base 1. Acid 2 plus base 1. For example, HCl is an acid plus H2O as a base give conjugate acid H3O positive and conjugate base Cl negative. In the above example, HCl is an acid since it donates a proton and Cl is an conjugate base. Water accept the proton and hence is a base. Thus, H3O negative O positive ion is a conjugate acid. A strong acid has a weak conjugate base and vice versa. Some other example of conjugate acid base are given below. Conjugate base. It is further important to note the Bronsted-Lowry concept is not restricted to only neutral molecules. The concept is equally applicable to ions as well. A careful inspection of the above discussion reveals that first, a substance is capable of showing acidic character only if their other substance is capable of accepting the proton. For example, a base. For example, HCl is an acid in aqueous medium because water can accept the proton from HCl. However, HCl is not an acid in benzene because benzene does not accept H positive ions from HCl. Second, not only neutral molecules but cations and anions may act as an acid or base. Both Arrhenius and Bronsted-Lowry concept require an acid to be a source of proton. Thus, all Arrhenius acids are Bronsted-Lowry base acids. Fourth, according to Arrhenius, a base is a substance which gives OH negative ions in solution. NaOH gives water Na positive OH negative. Whereas, according to Bronsted-Lowry, a base is a substance which can accept a proton. For example, carbonate ion plus H positive give bicarbonate ions. Carbonate ions CO3 2 negative cannot give OH negative ions because of ions in aqueous solution. It is therefore cannot be an Arrhenius base. Thus, all Bronsted-Lowry bases are not Arrhenius bases. Limitations of Bronsted-Lowry concept. Although Bronsted-Lowry concept could explain the shortcoming of Arrhenius concept, yet it could not answer some of the well-established reactions. For example, it cannot explain first the reaction between acid oxides like CO2 SO2 and SO3 which with the basic oxides like CaO, BaO and MgO which take place even in the absence of water. For example, CaO plus SO3 gives CaSO4. Clearly, Clearly, in this reaction between CaO and SO3, there is no proton transfer involved in the reaction. Second, the acidic nature of compound like BF3 FeCl3 and AlCl3. Lewis acid Lewis concept of acid and bases. G. N. Lewis in 1923 proposed a more general definition of acid and bases which is based upon the donation and acceptance of electron pairs. According to Lewis acid, an acid is a substance which can accept a pair of electrons, where base is an substance which can donate a pair of electrons. In other words, an acid is an electron pair acceptor. It means that a substance which has the vacant orbital to accommodate one or more pair of electrons can act as an Lewis acid. On the other hand, a base is a electron pair donor. It means a substance which with unshared pair of electron can behave as an Lewis base. Thus, the acid base or neutralization reaction involves the formation of coordinate bonds between the electron pair donor and electron pair acceptor. For example, the reaction between boron trifluoride and ammonia NH3 is a typical Lewis acid base reaction. Let us now discuss in detail Lewis acid. Accordingly to the concept, Lewis acids are classified as first molecule having central atom with incomplete octet of electrons, boron trifluoride, aluminum trichloride, etc. are acid of this type. It is clear too that the central boron and aluminum atom has only 6 electrons. Second, simple cations. All the cations are short of electrons and can behave as Lewis acid. Large size cation like Na positive, K positive, Ca2 positive and Ba2 positive etc. behave as weak Lewis acid. This is because these have the little tendency to accept electrons. On the other hand, small size cations such as S positive, Ag positive, Li positive ions have a strong tendency to accept the pair of electrons and strong Lewis acid. In addition, highly charged cation have the higher tendency to accept electron pair related to the charged cation and give metal. For example, SN4 positive is a strong Lewis acid than SN2 positive. Some of the typical example of Lewis acid base reactions are given below. Third, molecules in which the central atom has available d orbitals and may acquire more than 8 electrons. Compounds such as AlCl3, SiF4, SnCl4, SbF5, and SO3 and are Lewis acids where the central metal atom can expand its valence shell. Fourth, molecules with a multiple bond between atom and similar electronegativities. Carbon dioxide represent an interesting example of a double bond between carbon and more electronegative oxygen atom. Oxygen, being more electronegative, has a tendency to attract the shared pair of electrons to more toward it in CO2. As a result, it acquires positive charges on the carbon atom and become more electron deficient. Lewis acid and attaches with an oxygen of the hydroxide ion Lewis base. Similarly, sulfur trioxide acts as a Lewis acid toward water Lewis bases. Accordingly to the concept, Lewis bases may be classified as one that follow the following type of substances. First, negatively charged anionic species. All the negatively charged species are Lewis bases because they are rich of electron and have the strong tendency to donate electron pair. Common examples are Cl negative, O2 negative, OH negative, NH2 negative, etc. The greater the charge density on the anion, the greater the stronger is the base. Third, neutral molecules with one or more than one unshared pair of electrons. Molecules have unshared pair of electron act as Lewis bases. For example, NH3, H2O, R2O, and R2C double bond O act as an electron donor. Third, alkenes and alkynes with multiple bond also form coordinate bonds with the metal ion and organometal compound. Acid and bases reaction accordingly to Lewis concept. Some of the typical acid-base reaction involve the formation of coordinate bond between a Lewis acid and a Lewis base are summarized below. It is important to note that an empty orbital is being created to the sulfur atom by moving a pair of electrons on moving a pair of electrons from the double bond of the oxygen atom. It combination of cupric ion C positive. Fourth, combination of cupric ion C2O positive with ammonia. Fifth, combination of sanitic chloride with ethers to give an adequate. Lewis acid base concept discussed above is widely used because it is a simplicity. It is its because of its simplicity in understanding many acid base reactions. In spite of wider applications than Arrhenius and Bronsted-Lowry concept, it has several disadvantages which are discussed below. First, Lewis concept is too general and considered all reaction forming a coordinate bond to be acidic base reaction. This is however not always true. According to Lewis concept, some of the transition metals that forms compound with carbon monoxide such as NiCO4, FeCO5 etc. are acid base reactions, which is not correct. Second, formation of a carbonate coordinate bond between an acid and base is the basic of Lewis concept. However, the well-known acids like HCl, HNO3, and H2SO4 do not form any coordinate bond with the bases such as NaOH and KOH. Accordingly, HCl, HNO3, and H2SO4 should not be regarded as acids according to Lewis concept. Third, concept does not give any uniform scale of acid and basic strength. 7.4 Lifts flood concept of acid and base. A new concept of acid and base was proposed by Lux in 1939. This concept was further extended by Flood in 1947. Accordingly to Lux, Flood, concept. An acid if is a substance which accepts an oxide ion, where a base is a substance which give up an oxide ion. Thus, Lux food flood bases can be represented as, and Lux flood base acid can be tentatively presented as. Accordingly to the According to the Lux flood concept, that show a tendency to lose as well as an gain an oxide ion are termed as amphoteric. Zinc oxide represent an interesting example of amphoteric character. For example, zinc oxide can lose O2 negative to form Zn2 positive ions. In addition of zinc oxide gaining of O2 negative to form ZnO2 O2 negative zinc ions. Similarly, Al2O2 O3 can behave both acid as well as base in Lux flood sense, and hence and act as amphotericity. The concept of Lux flood is very useful at high temperatures, especially in glass, ceramic industry, and metallurgical operations. The concept of Lux flood can be also extended to halide and sulfide in place of oxygens. The concept of Lux flood can also be extended to halides and sulfide in place of oxygen. For example, unsandwiched concept of acid and bases. Unsandwiched concept of acid and base is very general and take into considerations all the concept of acid and bases proposed by Arrhenius, Fleury, Bronsted, and Lewis acid. In addition to unsuch concept, include all oxidizing agents as acid and all reducing agents as base. Thus, accordingly to Unsandwich concept, an acid is a substance first react with a base, second give up cations, third accept anions or electrons. Similarly, Unsandwich concept define a base as a substance that react with an acid to give up anions or electrons or combine with carbon cations. Some of the examples of acid-base reaction in unsandwich reactions are illustrated below. Thank you.